Okay, so let's start the second part of our lab, in which now before starting it, let's discuss the transistor we will be using. It's BFR30 transistor, which is a JFET N type transistor, right? So the maximum cutoff current at VGS is equal to, so that's the consideration at VGS is equal to minus 10. So at VGS is equal to 0 and VDS is equal to 10, we have a drain current of 4 to 10 milliampere, right? So a rough estimate, so it means approximately the applied voltage which we can choose is fine in the range of 12 to 15. So let's move toward the elements or the components which we will be using. So let's start placing components. Transistor, and it's yes, it's a BFR 30. Then we need set of resistors, 3K, 470, and 470 ohms, and the final is 10 mega, right? So yes, there's a 10 mega ohm resistance. Then I need capacitors, so let's move toward capacitors, and I need a capacitor of 10 mega. Oh sorry, it's 10 nano. So yes, 10 nano capacitor, then 100 micro, and 10 micro. What else do I need? I need a ground which should be in sources, so a DC ground and a source of DC power source. I guess that's all. Plus yes, I need a multimeter for my for biasing concept, just to clear your concept of DC biasing, and a function generator, and finally an oscilloscope. So let's initially see the biasing circuit. Now before going into biasing circuit, just select your show all element in your properties. It will give you a number on each line. Let me show you. When you are actually connecting, flip it horizontal, and connect your 12-volt source with your emitter, connect it with, now flip it, also flip it for your ease. Now these number which are present on each kind of node, these they appear by when you go into properties, and this is basically required, and show all, select show all. When I go into simulate and I want to draw the frequency response of this entire circuit, so these numbers are required at that stage. ठीक है, इसलिए मैंने आप लोगों को कहा है to select the numbers. Flip it again, 90. uh, Now this is your bypass capacitor, and these two are your coupling, right? So connect it with your, now connect, okay, I won't be connecting capacitors right now, because I just want to confirm my current. So change it into amplifier mode, and yes, definitely initially I'm current checking the DC current. So connect it with your terminal. Note that I haven't connected any capacitor so far. ठीक है. Now just run this initial circuit without giving any AC signal. ठीक है. Now just play it. ठीक है. And you will see that for these set of resistances, as I showed you in my calculation, my current is 1.89 milliampere. This was approximately what I showed to you for this set of calculations, and I roughly estimated a VDS, and I roughly estimated that where my quiescent point could occur. Okay, for this biasing circuit and these set of resistors and setting. Okay, this transistor and these resistors. So now let's move toward your let's convert it into the model in which we will be applying our input signal. ठीक है. So now when you open it, you can see the type of signals. ठीक है. Whatever your frequency is, your time in on your oscilloscope is just 1 over that frequency. ठीक है. And signal, because my range, as I showed to you, my range is approximately between 10 to somewhat 1.5. ठीक है, which is my saturation mode of saturation range. ठीक है. 0.8 के लिए this is my entire VGS, and my mode of saturation lies between um, 1 to 12. ठीक है. So it means that if my VGS is around 5, it means my quiescent point is approximately around 5.6, and my transistor is in AC is in class A operation. ठीक है. So I'm setting, I want to use any small signal, AC signal. ठीक है. Change it to, let's say, 10. ठीक है. 10 milli volts signal I'm using. ठीक है, which is basically a sine wave. So positive is connected with this side, negative will be connected to your ground, and इस side पे connect your capacitor. ठीक है. And connect your bypass capacitor, connect other end to your ground, and connect this side. Now there are two displays आपके oscilloscope पे. ठीक है, ये आपका हो गया with your, if I am connecting it in flip direction, तो आपका सिग्नल की जो वैल्यूज आएंगी वो थोड़ी सी इन्वर्टेड होंगी. That is all. ठीक है. Initially I am just connecting. Now I am changing toward AC signal. ठीक है. तो आप इसको, if you want to check your current, you can change it to AC. This is my entire connection. Now let's check it out. ये आपकी oscilloscope है. This is your signal. Let's play it. ठीक. Now note that the signal you have been giving to your transistor is in 10 millivolts range. So, and the signal I have connected, its scale is in 5 volt range. Drop it down to millivolts. ठीक है. So my signal is in 10 millivolts range, approximately 20 millivolts का signal. This is 10 on top, 10 on bottom. So आपका 20 millivolts बन रहा है. Make it 50. ठीक है. Increase your time scale. So this is your channel A signal. Now for comparison, ठीक है, comparison, this is basically your amplified signal. ठीक है, you can see its amplitude, it's 88. It means it's amplified version of your input signal. Now इसी signal पे let's stop it and हम connect करते हैं your positive and your negative with ground. ठीक. Now play again. ठीक. Now इन दिस सिचुएशन आपने इस ए पे सिग्नल दिया है आउटपुट का, बी पे आपने ऑसिलोस्कोप के सिग्नल दिया है इनपुट का, चेंज इट स्केल इन मिली वोल्ट्स। कोशिश करें कि दोनों स्केल्स आपके मैच्ड हों ताकि आपके पास एक वेरी वेल कंपैरिजन आए दोनों सिग्नल्स का, ठीक है। नाउ सी द वैल्यूज, ये आपकी टाइम स्केल है विच इज बेसिकली फ्लिप्ड ऑफ योर फ्रीक्वेंसी एंड नथिंग एल्स। दिस इज योर signal, amplified signal, and this is what your signal which is the input signal, ठीक है। आप इसको बेशक drop it down more, ठीक है, accordingly आपका signal change होगा। now you can also change it here, change your signal to 5 millivolts, accordingly आपकी amplifications change होंगी, accordingly आपकी match them, ठीक है, equivalent, ये आपकी A की वैल्यू आ रही है, B की वैल्यूज आ रही हैं। now this connection is actually flipped, इसलिए negative answers आ रहे हैं। all you would be doing is that when you want to calculate the gain, you are actually dividing your output voltage by your input voltage and it gives you the values of gain, okay, which you will be calculating in your lab. This is your set of lab requirements, okay. You will be noting your frequencies, input voltage, output voltage, and finally gain, okay. So when you are using an actual oscilloscope, this is basically a digital oscilloscope. This is your connection point. Suppose you are connecting it to your input signal, ठीक है। Suppose this is your output, यहाँ पे आपने input signal connect किया है। So what is happening here is that इसके साथ जो केबल कनेक्ट होगी उसमें दो लीड्स होती हैं, वन इज़ फॉर योर ग्राउंड एंड वन इज़ फॉर योर सिग्नल, ठीक है। सिमिलरली यहाँ पे आप कनेक्ट कर सकते हैं दिस साइड, दिस नॉब इज़ फॉर योर पोजीशन एंड दीज आर योर स्केल्स, ठीक है। यू कैन सी कि 5 वोल्ट्स टू 5 मिली वोल्ट्स का सिग्नल आपका ये ऑसिलोस्कोप रीड कर सकता है, ठीक है। इन दीज रेंजेस आपके सिग्नल रीड हो सकते हैं। यस, अगर इफ़ यू आर ड्रॉपिंग इट डाउन फ्रॉम 5 वोल्ट्स देन आपका ऑसिलोस्कोप इतना more precise oscilloscope if you purchase them, तो वहाँ पे आपका ये वर्क कर जाएंगे, ठीक है। लेकिन ये ऑसिलोस्कोप मैक्सिमम 5 वोल्ट्स को पिक करता है, दिस स्पेसिफिक डिजिटल ऑसिलोस्कोप, ठीक है। अगेन नेक्स्ट वन में क्या है, आपकी टाइम स्केल 5 सेकेंड से 5 नैनो सेकेंड्स की टाइम स्केल को ये ऑसिलोस्कोप पिक कर सकता है, ठीक है। यहाँ पे आपके पास जो ऑप्शंस हैं, लेट्स सी इट, it's in microvolt as well, ठीक है। so simulation आपकी microvolts में भी पिक कर लेती है। so ये आपको आइडिया हो गया होगा, ठीक है, आपने किस तरह इसको करना है। लेट्स मूव टूवर्ड द फ्रीक्वेंसी रिस्पॉन्स। जब आपने लैब ड्रॉ करनी है उसमें आप ये फिगर्स भी ऐड करेंगे। यस, वन मोर एलिमेंट, when these figures are coming you can stop it at any time, ठीक है। you can for noting your set of readings and ऑल डिटेल, ठीक है। आप स्केल्स मैच करें, ठीक है, अकॉर्डिंगली आप अपनी रीडिंग लें। वन डिवीजन, आपके कितने डिवीजन बनते हैं, ठीक। सो दिस इज योर AC current, ठीक है, माइक्रो एम्पेयर्स AC current. Now I've changed it to AC, this is IDAC, ठीक है। and finally I will move towards simulation and analysis, go for AC analysis. now this is for your response, ठीक है। drop it down to 0.001, right, and instead of logarithmic dB आपका जो scale होता है use it, ठीक है। output में you will be specifying your output voltage. now you can see this voltage, your this node number is 7, it means V7 is the voltage जिसका मैं frequency response check करना चाहती हूँ, ठीक है। so let's stimulate it. there are two set of responses. This is your amplitude for your frequency response, this is the phase for your frequency response. normally जब आप gain को study करते हैं, this amplitude is this is the actual response which is normally shown in your books, ठीक है, या आप अपनी theory में cover करेंगे, and it's in decibel, ठीक है। if you want to add this graph in your copies as well, ठीक है। और जो आपके input and output signals थे जो आपने oscilloscope से ड्रॉ किए थे, आप वो भी ऐड कर सकते हैं। so दिस इज़ ऑल फॉर योर लैब। एक्चुअल में आपने ऑसिलोस्कोप को जब रन करेंगे जस्ट डिफरेंस ये होगा, आप चैनल्स एक्चुअल में कनेक्ट करेंगे। जस्ट गो थ्रू द कॉन्सेप्ट कि इफ़ यू आर अप्लाइंग अ मिली वोल्ट सिग्नल, आप अपने स्केल्स को मिलीज के करीब जाके रन करेंगे, ठीक है। अकॉर्डिंगली आप अपने कर्सर की पोजीशंस चेंज कर सकते हैं, मींस बेस लाइन की जगह आप थोड़ा सा अप एंड थोड़ा सा डाउन जा सकते हैं। सो दिस इज़ ऑल फॉर योर सेकेंड लैब, and inshallah if you face any problem you can discuss it with me anytime, ठीक है। So that is all. Allah Hafiz.